Hello, this is Bohao here. Today we're going to talk about a question about tension forces, and we are solving it using dynamic equations and kinematics equations. So first of all, let's do a force analysis on this chart. We can separate this chart into 5 separate free body diagrams. So first of all, I draw the free body diagram of card 3, which only has force of tension 3 and its gravity and force of normal. For the second card, it should have the force of tension 3 on the left direction and force of tension 2 and 3 on the right direction, and the force of normal and force of gravity. For the first card, its force of tension is force of tension 1, 2, 3, and the left direction is force of tension 2, 3, and its force of normal and force of gravity. So if you combine those three, you would see that it only applies for gravity 1, 2, 3, and force of normal 1, 2, 3. But for card 2 and 3, if you combine these two together, it has force of normal 2, 3, and force of normal 1 and 3, 2 and 3. So let's look at the question first. So the first question has been asking to solve the magnitude of the acceleration of the cards. So let's go to GRASP steps. So what we know now is M1, card 1 is mass is 9.1 kilograms, M2 is 12 kilograms, and M3 is 8.7 kilograms. And the small g is 9.81 newtons per kilograms. And we already know there's a force applied, which is force of tension on the first card, which is 29 degrees, and 29 newtons, 23 degrees above the horizontal. And the R is acceleration. And we have to know that the M total is 9.1 plus 12 plus 8.7 kilograms, which is 30 kilograms. And we use the function F equals to ma, and we're using it for F equals to ma when we are applying for A. And we use this condition of 29 newtons of 23 degrees above the horizontal, and we can apply for the FAX, which is F net x, 29 newtons multiplied by cosine 23 degrees, which is 26.7 newtons towards east. Therefore, the acceleration equals to F on the F net x direction over m total, which is 26.7 newtons over 29.8 kilograms, which is 0.89 meters per second squared in the positive direction. Okay, let's move on for the second question. It is asking for the magnitude of the tension in the core between M3 and M2. So the tension force is acting on the rope 1 between the card 3 and card 2. Therefore, we will know that since the cars they move on the same seat, so their acceleration should be same, which is all 0.89 meters per second squared in the positive direction. Therefore, we use the equation F equals to ma. However, the force of tension on the first rope should be only force of tension F3. However, F equals to ma, and we use M3, A3, which equals to 8.7 kilograms multiplied by 0.89 meters per second squared, which is 7.74 newtons in the positive direction. And let's apply for question 3 now. Now it is asking for the force of tension between M1 and M2. In this case, the force of tension is applying two cards, which is card 2 and card 3. So in this case, we apply the equation F equals to ma, but this time we are using m2 plus m3. And the acceleration on 2 and 3, which is the same, multiplied by 0.889 meters per second squared, which is 18 newtons in the positive direction. So therefore, question 3 is 18 newtons in the positive direction. And we are done for the question. Goodbye.